So, right. So who understood the whole linking thing, or who didn't understand the linking thing? Yes or no?
Who understood and who did?
Yes. So
how?
Exactly. So it's I pitched the question first, and then I would say A or B. So who understood it? Okay. Who didn't? Honesty prevails. Yeah, cool. So then I'll clarify that. So we just did it in the break. Thankfully, someone pointed out they're still a bit lost of what's happening here. So just to clarify, we brought up a Mongo instance. So if you look at this command here, sudo docker run -- name mongo1 v /data /data/db /d mongo. So what's happening here? We're basically bringing up. Anyone wants to elaborate what's happening here? Please.
You're getting an image for the Mongo if it doesn't already exist, and then like deploying it or launching it.
Yes, you're deploying it. You're giving it a name called Mongo1. It's just an alias that you introduce for that instance, right? If you start a second one, you could call it Mongo2 or whatever you like, right? Well, whatever you like is relative. You can only use lowercase letters and characters and letters. And then you specify a volume you map it against, meaning everything that Mongo receives in terms of requests and data files it writes will actually be written to your local host machine. So meaning even if you lose the container, you still have the data. Right? Spin up another one and it will continue to work on the same data. Yeah, that's the thing we did. So that's the thing we set up, and we gave it the name Mongo1. That's the key right now. Then as a second step, we launched the container, the student container. I'll just should still be running somewhere.
Should you put the volume for the Mongo database to the same one that already exists on the computer, or should you make a new one? You mean the /d /data right now? Yeah, because
yes,
you could put that where you already have your existing like the data folder for MongoDB. I mean, hopefully everybody has MongoDB installed, and therefore a data folder for it.
That's right. That's right. So yes, you can absolutely do that. So that's the key idea there, that you link volume and you can reuse it, right? So you set up a new machine, just bring along that volume, and relaunch it on a different machine, and all your stuff should be, all the services and Mongo should be there again. Only critical thing to be mindful about: the data formats of those files may change. So if you're not using the same Mongo version, you may actually run risk corrupting your data. So, but if you can guarantee that it's controlled, then you'll be fine, right? So, but yes, please.
Why are you leaving out the /db?
Because in this case, just for exemplifying, I don't want to. I just put, for example, all MongoDB data just under data on my local host machine on the class instance that runs on OpenStack. It's just a different location on a different virtual machine. I could also just say /mongo : yeah. So the -data just says where it's mapped on the virtual container instance. The other one just says how is it linked to the local file system on my current machine, right? Cool. Right. Cool. So we have this instance running. Afterwards, I ran just to recover the command, see if we find that somewhere. No, that's not the one. Well, I'll just type it out, I guess. Docker run -- name. We give the other machine a new name. I just reconstruct the command as it was. Port 8080. And then the key was to provide the environment variables. One of them was port equals 8080. The other one -e is db host equals, and that's where Mongo comes into play, Mongo1, and I get to that in a second, and we say something like link Mongo01. So, and we need to specify the image we're building off, which was something like student db tech04, right? So I think that's roughly it. So this command, I will not run it because we'll just fail because we already have an instance running, but it's fundamentally command. So it brings up a Docker instance with the name student ID 2, links the internal port 8080, which is the second 8080, to the host's 8080, which is the first one, and injects the environment variables port equals 8080, so they will be available to the Docker image internally, and db host equals mongo1, again into the Docker image, so meaning from Docker running os.getenv. I'll just bring up the code for that, so you kind of, you hopefully see the link. So recall that yesterday we did some modification of the Docker code for the studentDB example, and the thing that we did was basically introducing the variable here. It's hardly legible. Give me a second. There you go. db host. So we have a new environment variable db host that the system assumes exists, and it will just substitute the previously hard-coded URL here against this host variable. Yeah. And the other one was the port one that we know already from Heroku, right? No surprises there. Yeah. Everyone somewhat clear about this? Yep, please.
So, I'm not entirely sure how it is able to find MongoDB just from MongoDB at localhost, or when you specify that it's using this container, because it's just a container. How does it know where?
Yep. So yeah, unless not specified. So if you look at the API for the dial command in Mongo v2, it will look for the default port on a given host. So if you don't specify the port explicitly, it will just use that IP address, which localhost resolves to, right? Localhost resolves to 127.0.0.1 and so on. It will just look at port 27.0.1.7.
Okay, so it has the the container sort of exposes that port from within for other containers, but not outside.
That's right. So yes, so that's what MongoDB does, right? So it exposes that default port because there's basically just running a Mongo instance there, and if you don't specify it explicitly, you just run MongoD as you guys did for your debugging your own assignments. It will just expose it on port 27.0.1.7.
Okay, so for a container, all ports that you sort of use within the container are exposed to other containers.
That's right. So here you see that the port 27.0.1.7 is exposed within the container network here, right? So I mentioned that this is like the boundaries of Docker basically here. And within this port, as you just mentioned, is basically exposed on 27.0.1.7 and available to all possible other containers. The only tricky thing is though, how do we know which instance we need to connect to? That's the magic we didn't really solve, right? And this is where the linking comes in. Was there some raised hand I may have overseen?
Later.
Okay, cool. So the only thing that we don't know, so we know the machine right now, or sorry, we know the port right now, but we didn't really specify, help the system how to identify the machine. The idea is there that this command, --link, injects into the Go container, right, the service container, the information of what Mongo 01 maps to, because internally all those containers have unique IP addresses, so we could address them by IP address, which we don't want to do because they are dynamic, they can change, and we don't want to hard code that kind of stuff. It's too low level, but we can hard code names against it. So the idea is there, if the Go container knows, similar to DNS, have some sort of name resolution system where we provide a given name that resolves to the internal IP, then this container, when addressing Mongo 01, will resolve this other container that contains the MongoDB instance. Yeah? So it's basically like a domain name service internal to Docker. Right? Technically it's done slightly differently, I'm not going into that one, but the idea is that if you specify this --link, the instantiated Go container, studentDB here right now, will know that Mongo 01 points to another machine. Yeah. And then if we tell the Go application to use the db host Mongo 01, which we did as part of the command, again db host variable, then it will try to access that very host. So we tell Docker itself where to find the other host, and then we tell Go which host to connect to, right? So we're basically delegating throughout the entire chain from application level to network level the connectivity between different containers. Does that make sense somewhat? If we were not specifying the --link, Go would know what container it wants to connect to, but Docker wouldn't know what that means, right? So if you were not specifying that link and you would tell your Go applications, please connect to MongoDB on port 27017 because that's where Mongo usually lives, then the environment, the Go container environment would say, no idea what Mongo 01 stands for because I don't have an explicit link. Yeah. So only if we inject this dash dash link will this container know which other container it refers to. Yeah? Please.
So Go itself doesn't know that student DB04 is a container. It just believes that it is a.
This one. Yeah.
Yeah. So it just believes that that is a client or a server.
It will treat it as a server. Yes. Yeah, that's right. It's inherently agnostic about the fact that it's actually a container. That's the idea, right? Because all the applications you write are basically written to be run on your machine, right? But nevertheless, they run in virtual machines. Nevertheless, they should be able to run in containers. So yes, the abstraction layer provides an environment that leaves the software with the impression that you're actually running on a physical host. Yeah, absolutely right. Absolutely right. So we need to work around all the constraints and characteristics that are involved in this. That's why, again, infrastructure as a service. We need to think about how do we model the infrastructure that realistically exists, like all hardware constraints and so on, and including networking as shown here, so that the code works as it does before. So even legacy code doesn't need to be rewritten in order to be Dockerized, right? Yes, you may need to inject environment variables, but it's also always part of the programming language that you're dealing with anyway, right? So, but you're not customizing again, let's say, against Docker library or the like. Yeah. So that's the key idea. We keep applications generic. Fundamentally, it's just a minor modification of the Go application that ran on Heroku, which can now run on Docker, right? So the only thing we changed was really this Docker DB host variable that we're now using. Yeah. No? Good. Somewhat clear? What? Cool. All right. Let's write a. Then another comment that was raised just before. I just want to make that explicit as well. Again, was the launching of an individual Mongo container. So while we put quite some effort into launching the Go container and building a Docker file, we actually did, we just talked about it before. So we actually don't need to do that, right? So we can just use a ready-made Docker image, which is automatically downloaded. So it's one line away from instantiating a Docker Mongo instance. Okay, so let's use Dockercompose a bit. See if we come up with a working YAML file relatively quickly to solve it. Okay, we have everything we need. We have our Docker file that needs to sit. So first of all, we need to indicate the version of the YAML file. So versions change over time. If you want to see the changed features, check the Docker reference. It's quite explicit about the new instructions that are added over time. So it's still a kind of dynamic environment in this respect. So one of the first things we need to specify are the services. And we have two services. One we call web or Go. Doesn't matter as long as it's a unique identifier, right? So we just call that web right now. Let's be explicit for the first iteration. So we can declare the environment variables, and the ones we need is really port equals 8080. So we're exposing everything in the Dockercompose file for now, and the DB host is don't know yet. So we'll see about this. Then we need to specify a build context. So right now, remember that our web service here, or Go service, Golang service, needs to be built from a Docker file, right? We don't assume a ready-made image. We need to build it from a Docker file. So we just need to tell the system where to find that Docker file. And that is current folder. So we assume that this file here, Dockercompose, lies in the same folder as the Docker file that builds the Go service. Yep, cool. Other things, so no magic here. It's all the stuff that we have seen elsewhere. It's just the ports that we need to specify. In this case, it's 8080 to 8080. We still stick to that convention. And this service depends on another service. Hang on, depends, the syntax is like that. So we need to indicate which service it is. And I think a reasonable name for another service we could depend on would probably be DB. And so we name it DB. That also means that the DB host will be called DB. So that's service number 2. So service number 1 is done. It has all the components that we have dealt with before. We have the port, we have the machine we should connect to, or container, the exposed ports. And the only new thing is basically that we're saying, well, you will depend on another service. Please.
Is this the dash name variable?
This is basically the dash name variable. You're absolutely right. If you translate it to a Docker command, that's exactly what it is.
So now you don't have a choice.
Well, you will see once we spin them up, actually it's not the dash name, it's the unique identifier on Dockercompose level, because it will give them unique identifiers based on its conception of unique identifiers. You know what I mean? So you can spin up multiple instances using Dockercompose, but they would clash if they had the name DB, you know? So it will call them something like Dockercompose DB01 or something like that. We'll see that in a second. But fundamentally, it's the unique identifier. But it will deal with that abstraction for us, so we don't need to worry about this. You will see it's literally one command away. So for, we just use Mongo right now because I'm not sure if the internet is helping me today, and we have volumes attached. So that's the Mongo database. We literally build off an image. Let's just be lazy and use the latest. Obviously, in production code, you need to want to narrow it down to something more specific image. Again, you want to have compatible. You want to know which version of Mongo is writing your data files, so you know which version to use to read them in case you need to, restore them and the like, right? But that's something for you to figure out. So then we have a volume, which we specify here, when we call it DB data, let's say, and we link it in the MongoDB instance to that location, because we know that's the location where Mongo stores its files by default, right? So you did this when setting up your own MongoDB instance. So the only thing we still need to specify is basically the volumes, just as a unique identifier. We just take a system, well, DB data apparently is a volume. That's all we need to do. So, and I think this should be all to bring up this entire service. So let's try it. So first of all, write that file. Sudo docker, we need to bring down our containers right now. So we have two running, sudo docker stop student02. And we probably also simply delete this, sudo docker rm student02. Doesn't do code completion, so that gets, hang on, right, it deleted it. I used the --rm command, so as soon as I stopped it, it was automatically deleted. And then we have the other one, sudo docker stop mongo. So we're basically removing all the instances that we have manually spun up. It takes a bit longer, but it will eventually shut down. Yep. So so if you run sudo docker ps right now, we don't see anything. Do we have still existing containers? Yes, we have. We have in fact two containers, and one of them was one of the failed ones. So I will just remove both of them. So I have a clean slate here right now. So number one, get rid of this. Again, rm means delete containers, rmi means delete images. Yeah, so we need to differentiate between those two ones. Takes a while. We'll see what OpenStack is up to right now, but it may take a bit. Come on, and get rid of Mongo. Cool. All right, so where's our Dockercompose file? Sudo Dockercompose YAML. No, just up. So what it will do, this command, Dockercompose, will look into the current folder, look for the dockercompose.yaml file, and hopefully bring it up. If we don't run it detached, there you go, it actually does everything it should do. It builds the initial container, it brings up the services. So now you actually see the real name or aliases of the containers. Well, that was a bit fast, but they're called studentdb docker _ db1, and then the other one is web one, for example, right? So it would allow you to bring up multiple web servers, for example, that access the same database, and Dockercompose itself would ensure that you have unique identifiers. Yeah, so that's the first step towards scaling up. If you say we need actually, well, based on the high demand, right, 5,000 requests a second or something like this, we actually need to scale up the web service, you know, and this would be our way to do it. So we can actually just instantiate multiple containers on that part only and leave the database as a single container. So that's the output from the database that you see. I intentionally just ran it without any option, meaning without the -d, just to see what the output is. So it's good for debugging. You notice it's coming from the container db1 here. Yeah. If you run Control-C, it brings everything down, and that's basically that. If you want to run it detached, you use the which option? Anyone? Any guesses? We didn't talk about it. -d, right? So yeah, so in this case we'll bring it up in the background, but in this case we just wanted to see that the system is actually coming up. Any output you see here specific to the service. This is not Docker output. And once it's shutting down, that's usually a part that takes a bit longer, because it also needs to disassociate all the volumes, the network interfaces, and so on. It's quite a bit of work. The name mapping needs to be solved as well. So see how that.
When you spin up the,
yep.
If you want to spin up several web containers,
yeah,
with different names, they also have different ports.
That's right. It would introduce a additional. Yep, something went wrong. Cool. And let's see, can we track that down? That is specific to Docker. Some Python script has failed. Threading has failed in line 801. Okay, that's Docker specific. Interesting. Well, it can happen, right? It's a technology in development. I'm running Dockercompose version 17, so it should be stable, but perhaps it's not. So, well, c'est la vie. But in what was your question about the? Yes, the networking. So it would do load balancing on its own. It would introduce a new node that preempts. So basically, it would be called web or whatever else. And all the requests would be directed towards that node, and it would automatically load balance and distribute it across the attached instances that sit behind it. If you have 5, for example, instances of the web service, it would dynamically ensure that they have a equally balanced load. Yeah, so that's done automatically, but that's the next step. That would be building towards Docker swarms. We're not looking at this now, but that would be the next step. Hang on. So this would be the same thing right now. It's just doing it in the background, so we can actually inspect how it looks under the hood. Again, it takes a while. Again, there's a lot of stuff involved. We need to set up the networking, potentially build the images. We don't need to do it now because the image has already been built. Attach network ports, attach volumes, and expose the port 8080, for example. And once it's done, we just look at the running environment.
Is this now done deploying on OpenStack? Has that been set up now?
This is it's running on this local machine which works or operates on OpenStack, but we're working on a single instance right now. We didn't talk about distributed computing at all. In fact, it's just virtualized computing in one OpenStack instance that runs Docker on top of it. So that would be the next future step. If you have multiple instances, you can link them together into what Docker calls a swarm, and then dynamically distribute the images across the individual nodes. But again, you can control that to some extent. Oops, that was not what I expected. So it seems to be extended timeout. But it would distribute them across different hosts, and you would be able then to dynamically organize the underlying virtual hardware and the software services running on top of it. That's the key idea here. So let's see what's actually running, because that didn't really work well. It worked the first time, but didn't come down anymore. So that's a tough one to debug, but we'll see what we get. So sudo docker ps. So there is the DB is running, and if we run ps-a, we'll see that we have 2 images. And actually build this. But the interesting thing here is notice the names. So it automatically names them accordingly. In this case, it's studentdb docker web01 and studentdb underscore db01, right? So if you have multiple, there's still space for unique identification. Yeah, that didn't really work. Well, it kind of worked, but for whatever reason, it came down a bit quicker than I expected it to. So it's a bit of a pity. So The other thing that I wanted to look at, there was the idea, or that you guys suggested we should do, is the environment variable thing, right? So that's the next improvement that we need to introduce. I need to debug whatever happened there in the Docker infrastructure, or my installation possibly. DB host, and we just pointed to DB as a potential host. Those are two variables that we are dealing with in our environment. And the idea is now that we just, instead of explicitly specifying them here, we get rid of that entire section. Just say env file, and then in the next line indicate which file we're actually dealing with. .env. Yeah. So that's then suddenly reasonably committable without being worried too much about potential challenges. So what I'm doing now is Dockercompose.
But why still have environment variables if you're referring to a variable like env file instead? Like,
Again, sorry. Yep.
Why still define things like port and like a MongoDB host if you're referring to environment variable file?
Commented them out.
Well,
Commented out.
What were they?
Oh, yeah, I commented them out. I just wanted to show the two ways of specifying. I can just clean it up if you like. That's probably a better way.
Oh no, I just didn't see they were commented out.
So that's right. No, sorry. I didn't mean to confuse you, but rather to show there are different ways. So, cool. So, so now services, both of them are stopped. Let's see if they're, I just want to see if they're still running. Dockercompose, Docker PS. So that's how the two things link up. So they're definitely not running. Are they still existing? Yes, they are. And now let's just delete them. Dockercompose rm, and it will delete all the services. In this case, will ask me. If you don't want to be asked, you need to have an -f for force, and then we'll do it automatically. But the idea is really to have a very simple command solution where you just run one command, bring up your entire infrastructure, and yeah, well, I guess lean back hopefully, but let's see again. But it should be reasonably straightforward, right? So is everyone somewhat clear of what we did just now? Yeah, so now we have the entire infrastructure up. We have created a new DB service and a new web service. Cool. So if you look now, we see in the background here, they're basically running. We see the unique identifiers. So we could now basically, directly operate on the containers, but we obviously didn't want to. We now delegate the entire management of the containers to the Dockercompose file. Yeah. So we don't actually directly deal with the underlying containers anymore. So we don't need to deal with any complex command line options and port associations, dependencies, and all that kind of stuff. Dockercompose will take care for us, and we simply are one command away from doing so, right? So that's the key idea. So yeah, so a few more. So that's basically what we set up right now. So we have a fully running system that basically just builds on individual Docker files or images. So again, the Mongo image was not a Docker file, it was just an image directly downloaded from Docker Hub and this Dockercompose file. There are way more things that we can specify. Things, for example, here's an example for CPU and memory allocation that we're not dealing with, but this would be getting closer to the swarm option of Docker, that we're actually distributing across different machines and want to and control how much memory we can, for example, use for a given service, right? Those can also be used as threshold to spawn up yet another instance of a particular machine,
what's the
container.
Like when you dedicate memory and say, well, this container gets 50 M of memory. What's that, megabytes?
Megabytes, yes.
Okay.
So in this case, that's the limit. That's the max memory it can consume. The reservation is the minimum memory that's allocated, fixed, guaranteed, allocated. Yeah. So we can't over allocate. Yep. Please.
Is that 50%?
Yep.
Of a CPU?
Yeah. 50% and 25% is the minimum reservation. So anytime that service, Redis called here, Redis database, requires processing power, it will get up to 25% guaranteed, and if possible, up to 50%. Yeah? So
So then you will like get errors, I guess, if you're trying to deploy too many containers that all require too much CPU.
That's right.
You will be like, well, if we deploy this thing, we can't actually give all the things the CPU power needs.
You can't guarantee the reservations. The limits are secondary, but the reservations are the key. Yeah, that's right. So, but this is basically just the next level now, that we start controlling the infrastructure. Previously, we only controlled networking. Here, this is about controlling CPU to some extent. This one is about controlling service behavior. So here, for example, we have a restart policy, which says, well, on the condition that you have a failure in your service, just restart it maximum 3 times, and attempted with a delay of 20 seconds, and have a window of 120 seconds to assess whether it was successful or not, right? Your restart. That's the key thing. You can also say always restart, so if you blindly commit to always restarting, or don't restart at all. Yeah. So in this case, nothing would happen. So those are further features. Again, we talk about networking. We can have multiple networks in there, so we separate containers into different networks. Front and back end is a classic example. We can do logging, for example, as well. So those would be the advanced next steps. If you are keen and interested, I'll point you to the Docker documentation about the compose file structure with examples. This thing is huge and has been grown over time, and largely it really depends on the features you're interested in. So you can actually do quite a rich setup of things. So from here, the next step using Docker from beyond Compose would be to think about services as a way of managing multiple instances of the same thing. So here, for example, you could indicate that you want to deploy a web service based on that image and so on from 5 times. So you have 5 replicas that just waiting to be used. And they would be connected to the network webnet. So any request to the network webnet would then be load balanced across those 5 instances. Yeah? Those instances have a limited use of CPU and memory, and there are particular restart policies attached to them. So this would be the first step on scaling up your system. If you want to say, well, actually I want to have 5 instances of my web service. Yeah? So that's the key idea. The rest is the same. Here again, notice now, we didn't do that explicitly because we didn't specify our own network, but you can specify your own network and then just link individual services to it. So you have multiple networks you can work with. And then beyond this, so this is still on one single host, but then you can move beyond this and think about swarms. And that is really about attaching individual nodes in a network to one swarm, which is managed by one swarm manager in Docker. And it would dynamically distribute all the different containers based on availability of memory and CPU across the different nodes. So it deals with automatically with the underlying infrastructure and provides a swarm load balancer that allows you to access those services across different machines. So it ultimately deals with those requests and balances across all the instances. But this is a step which is beyond, right? So the simplest step is single container. Next step, managing entire systems with multiple containers. That's as far as we got, Dockercompose. Next step is to think about scalability of individual containers. So multiple web services as opposed to single database, for example, right? Scalability within the application. And this one is scalability across hardware. Yeah, that's the next highest level. So there, where it's really about rolling out across a more massive infrastructure. Probably something we don't have the time to explore. But having a Docker build files and the compose file, I think is a good baseline of getting started. That's a good deliverable for any systems operator to hand over to the specialist and actually scale it up your application based on demand. Yeah. So that's as far as we get here. Yeah, please.
Does Docker Swarm and Kubernetes do the same job?
They do the fundamentally same job. But Docker is Docker specific, so Docker containers only. And Kubernetes is way harder to set up and slower. So it takes longer for individual containers to spin up. But it's more generic in terms of the underlying infrastructure. It can also spin up VMs, so it's not necessarily relying on container technology only. But yeah, it's more heavyweight. Even the setup is much more involved. So if you want to try things out and want to play with scalability, I think as a first step I would go with Docker Swarm, and only if you hit limits there, then it's worthwhile looking at Kubernetes. Yeah. So yep.
Would the third node initialize a third web app if it assesses that the other 2 are overworked?
That yes, so you can specify those limits for load or requests, and then it would spin up yet another instance of a container on a underused node. In this case, node 3, for example, it doesn't have any container, so most likely the manager, it's at the discretion of the manager, would actually spin it up on that machine. But you can also tag containers or services and only run them on particular nodes if you like to, which is not recommended. But sometimes you know your hardware, underlying hardware situation, right? You have a few slow machines and one really powerful one, so you want to ensure that one service always runs on that most powerful one, perhaps for number crunching reasons and some. But by default, you should have a nice abstraction from your hardware. You shouldn't need to think about it and leave it to the Docker Swarm instance to deal with the distribution, right? So in the ideal case, you would have a uniform set of underlying physical or virtual machines that you could use. And again, the whole thing is independent of whether you use physical or virtual machines, right? So the nodes are basically signing themselves up. We're using a Docker daemon and publish their own IP address to the manager, and from then on it just takes over. And it doesn't matter where it's running on. It could be a physical machine, could be a hybrid mix between physical machines and virtual machines, or purely virtual. Yeah. So it's inherently up to the underlying hardware that's there. Because at that stage it shouldn't matter anymore. You have one command that manages everything. Any thoughts or questions?
So in theory, could I, when I'm home for Christmas, I could hijack all the machines in the house and deploy Docker on them?
Yeah, absolutely.
Orchestrate between them?
Yep.
Without, like, running in the background?
Yep.
Without anyone noticing?
Well, they may notice a load on your machine, but no, other than that, no. Yes, absolutely, absolutely. You have a Docker daemon running?
Thought experiment.
Oh, no, it's a practical experiment. I encourage you to do it and share your experience. That would be interesting. But absolutely right. So it's headless service. So if you have the GUI there, good for the one who uses the GUI. But in fact, it's just running in the background, and you have the dynamic scaling. Yeah.
Can you deploy Docker on phones or iPads?
No, right now, that's one of the limitations. I think Docker, we still need to get to that stage where we have mobile cloud environments where we can actually have cloud environments running on mobile devices. Right now, Docker, absolutely no. It's even tricky to run it natively on Windows right now. So it's still in the early stages. But that's not the prototypical application for Docker, I think. So that's really more back-end server provision. But there will be other solutions coming up for cloud computing on mobile devices, so mobile clouds. Yes, or fog computing, as it's also referred to. Cool. Questions further? Sweet. I will upload the Dockercompose file we have and the Docker file and so on into the repo and publish that repo so you can review the files and use them. So for your assignments, should be relatively straightforward to adapt many of the tech, of the stuff we talked about. For me, it's really more opening a bit of a perspective of how you can go from here, right? How do you actually manage microservices? Right now, we manage two microservices. One is the database, the other one our, good old Golang web service and so on, and brought them up as a coherent system. So we have one system now to manage all of them, and from there on you can go move on and find other more advanced use cases, right? So such as Docker Swarm. Good. So I leave you with this for now, and see you perhaps later tonight, ones that want. Yeah, cool. Thank you very much.